What are isotopes? Isotope is a word that gets thrown around in chemistry a lot. So what are they? Really quickly, isotopes are different versions of an element, or different versions of a certain kind of atom. This can be a tricky concept though, and a lot of people get confused by isotopes. So I want to describe them by starting out with an analogy to cars, okay? I want to talk to you about the made-up car called the Lamona, the epitome of luxury, and it's known for its very distinctive styling. As you'll see, the Lamona looks like a lemon. Now, the Lamona comes in 3 different models. There's the Lamona G, the Lamona GX, and the Lamona GXL. They're all different colors, as you can see, but each of these models also has unique features. One has a radio and leather seats. The GX here has chrome wheels and a CD player. It's blue. The red GXL has massaging seats, platinum spinner wheels, and everything. But here's the point. They are all Lamonas. They're all Lamonas because they all have this distinctive styling. They look like a lemon, and that's what makes a car a Lamona, okay? So it doesn't matter what color it is, and it doesn't matter the various options that you get in these models, the GX or the GXL. What matters is that they all have this particular shape. That's what makes a Lamona a Lamona. So we have these 3 different models. I want to use this analogy now to talk about the same thing but with atoms. I want to now introduce you to 3 models of carbon, just the way there are 3 models of the Lamona. Okay? Here are the drawings of each one of them, and what we're particularly concerned about is the nucleus. I'm using these red dots to symbolize protons, and I'm using the blue dots to symbolize neutrons. The swirly circles are supposed to represent electrons that are buzzing around the nucleus, but we don't really want to worry about that too much right now. Anyway, these 3 models of carbon are carbon-12, carbon-13, and carbon-14. Let's look at the options in them. Like we did with the Lamona, let's look at how each one of these different types of carbon differs. Okay? So, if we count the number of protons in carbon-12, we'll see that it has 6 protons, and if I count all the blue spots here, I have 6 neutrons. Okay? Carbon-13, 1, 2, 3, 4, 5, 6. Red spots, 6 protons. In this one, I have 7 neutrons, and in carbon-14 down here, I have 6 protons, and I have 8 neutrons. So what do we have in common here? All the different models of the Lamona, even though there are things that they differed about, all have the same distinctive lemon-like shape. So for carbon, what they all have in common is they have 6 protons. 6 protons in the nucleus. And that's what makes a carbon atom a carbon atom. Okay? So it turns out that it doesn't matter how many neutrons it has. 6 neutrons, 7 neutrons, 8 neutrons, no big deal. It's just like painting the Lamona different colors or adding a radio or a CD player. The neutrons, it doesn't matter. It doesn't change the fact that each one of these are a carbon atom. That's because carbon is defined by the fact that it has 6 protons in its nucleus. If you look it up on the periodic table, you'll see something that looks like this, and the number up here is the atomic number, 6, which means that if an atom has 6 protons, it's carbon. Okay? So that's what these all are. They are all isotopes of carbon. They're different versions of carbon or different models of carbon with the same number of protons and different number of neutrons. So look at how I wrote this. I've got carbon-12, carbon-13, carbon-14 up here. I want to take a minute and talk about the numbers. So the number of protons in the nucleus, we call that the atomic number. You may already know that. And then carbon-12, this 12 that I've written here, refers to a different number, and we call that the mass number. The mass number, as you'll see, is the number of protons plus the number of neutrons. So this is carbon-12. 6 plus 7 protons and neutrons is 13 here. 6 plus 8 is carbon-14 here. So that's how we distinguish between these different isotopes, different types of carbon. There's another way that we sometimes indicate these different isotopes of an atom instead of doing 12 and 13 and 14, and that's by using something called isotope notation. Let me show you how we do that. The way we write carbon 12 or 13 or 14 in isotope notation is we start out with a chemical symbol. If you don't already know that, you can find it on the periodic table. So here it is. It's a big uppercase C. So I start with my C for carbon. And then on the lower corner here, I write the atomic number. So that's going to be 6. And then up top, I write the mass number, which is 12. So this is carbon 12 written in isotope notation. Carbon 13 is going to be 6 again, because all carbon has 6 protons in its nucleus. But then the 13 up here. And finally, carbon 14, written in isotope notation, is C614. So that's how we can write all these isotopes of carbon in isotope notation. Then, of course, you can also write it as just the element name with a dash and then the number. So carbon isn't the only type of element that has multiple isotopes. In fact, just like cars, almost every form of element comes in multiple isotopes. Here are the calcium isotopes, for example. If you look up on the periodic table, you'll see that calcium has an atomic number of 20, which means that any atom that has 20 protons in its nucleus is calcium. But just like with carbon, you can vary the number of neutrons that are in the nucleus. You get all these different isotopes, but you still have calcium. Calcium, we've got 40, 42, 43, 44, 46, 48. All of them have 20 protons in the nucleus, but they have varying numbers of neutrons. Just like we did with carbon, we can write all of these calcium isotopes in isotope notation, where we have the mass number here up at the top, and the atomic number down at the bottom. You'll see they all have the same atomic number of 20, but different mass numbers, the sum of protons and neutrons. The same is true for iron, just to give you another example. Iron has 26 protons in its nucleus, an atomic number of 26, and there are 4 known isotopes of iron, all of which have 26 protons in the nucleus, but they all have varying numbers of neutrons. You add these together to get the mass number, and then you can write it in isotope notation with a mass number up here and the atomic number down here. So just to review what we've talked about, atoms come in different versions known as isotopes. These are like the different versions of a car or something. The number of neutrons change, but just as long as you have the same number of protons, you still have the same type of atom, the same type of element. You can take an atom and write it in isotope notation, where you put the atomic number on the bottom and the mass number up here. So that's what isotopes are.